I'm going to call this, let's say g. So it's g over x plus 3 squared and x plus h plus 3 squared, everything divided by h, correct? I didn't want to copy all this, so I called it g. Now, from here, we copy the fraction from the top, but then we have to flip the fraction from the denominator. Because when we divide a over b divided by c over d, this is a over b times d over c. So when we divide two fractions, we copy the fraction from the top and we multiply by the multiplicative inverse of the denominator. So the denominator is h over 1. Everything is over 1, but I have to flip it because I have to divide them and it changes into a multiplication. So that's how the denominator became this. H, x plus 3 squared, x plus h plus 3 squared. Was that the question, Marita?
Yes, yes, thank you so much.
Is it clear now?
Yes.
It's because of the division of fractions. And h is the same thing with h over 1. 5 is the same thing with 5 over 1. 0 is the same thing with 0 over 1. X is the same with x over 1. So this is h over 1 that I needed to flip at the end. Perfect. Other questions for me, please? Other questions? Okay. So that was how we evaluate functions. Okay. The next step that I would like to discuss is finding which of these are functions. Is this a function? 47. From the graph.
Yes.
Yes, by the vertical line test. Is 48 a function?
No.
No. By the vertical line test, if it's a function, any vertical line has to cross the graph in exactly 1 point. I should say not more than 1. It doesn't have to cross it.
Wait, can you say that again, please?
Yes. By the vertical line test from college algebra, by the vertical line test, any vertical line through the domain of the function cannot cross the graph in more than 1 point. Here, this vertical line crosses the graph in many points. Here, it's not a function. It crosses in many points. This is a function. It crosses once. This is a function. It crosses once. This is a function. Every vertical line crosses once. Every vertical line crosses once. Here, no. 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 Here, yes. Even this line crosses once. This is not a point. This is an open point, empty. It crosses only once. It crosses here, not here. It crosses only once. Here, this is not a function because it's sufficient to show that I found one vertical line that crosses the graph in 2 points. So this is not a function. I don't have to show others. Just one is sufficient. Here, it crosses only one. So all these are functions. Good. Now, I do have 4 minutes left. So in those 4 minutes, I didn't get to this. I really wanted to get to, yeah, there is a chat for me. No, okay. Good. So I didn't get to this. I'm going to keep it for Tuesday. So what I would like to do is talk about I know. I just touched the computer. I know. So I just want to talk about, in the rest of the 4 minutes, I want to talk about piecewise defined functions. Functions defined in pieces. And I'm just going to show a very simple example and then we'll elaborate next time. So please choose a simple example, anything from here. Which one?
65.
65. Very good. So in 65 we have f of x equals 1 for x less than 0 and negative 1 for x greater than or equal to 0. Every time we are asked to graph a function, the first step must be domain. So we are asked to graph. It's a piecewise defined function because it's defined by two branches, or 3, or 4, or 5. So it has two different branches. What is the domain? Can anyone give us the interval notation for x less than 0? How will you write the interval notation for this? From negative
infinity 0
to 0 with a parenthesis. Awesome. What about the interval notation for this one?
0
With a bracket, yes, because it's including, yes, and it's 0 to infinity.
0.
Good. So can anyone look at these together and tell us the domain of this function?
Negative infinity to infinity.
Excellent. Very good. Thank you so much. So domain is everything. There is nothing missing. 0 is a very important value. Oh, I saw that. 0 is a very important value. So it has to be in the table, this 0 here. Notice that there is a parenthesis to the left and the bracket to the right. And they are touching. They have to be touching. The function is defined everywhere. The first piece, from negative infinity to 0, I have to replace it with 1. That's what I have. And the other side with negative 1. So there is nothing I can plug in, but I have to have some values. So for negative 1 is 1. For 0, inside the parenthesis is 1. For 0 is negative 1. For 1 is negative 1. For 2 is negative 1. So I'm ready to graph. You do not have to do this, but I will always do this just to remind my students that there are two different branches. At negative 1 is 1. At 0 is 1, but it's an open point. And this is the graph. Put this away. Now, at 0 is negative 1, but it's a full point. It cannot have two full points. This is an open because it's a parenthesis. And this is a closed because it has a bracket. And all the way negative infinity. To know towards negative infinity is negative 1 everywhere. So if you extend this line and you extend this line by the vertical line test, this is not a function. So notice that 1 is only between negative infinity and 0, and negative 1 is only between 0 and infinity. 0 to infinity.
I have a question really quick.
Yes, please.
Is there a way to graph that in the calculator instead of like writing it out?
No, but this, yes, there is a way. It's a little complicated way, but you have to show all the work for full credit.
Oh, I see. I just didn't know if there was an easier way to
No,
do it.
no. We can do this with a calculator, but it's sophisticated. It's not an easy fix. So can anyone give us the range of this? And we stop. Thank you. I didn't mean to hold you a minute over. Can anyone give us the range of this function?
One and negative one.
Exactly, but written like this, with braces, not parentheses and not brackets, because there are only two values. Thank you.